Okay, so this is my presentation on hydrokinetic energy. So let's just hop right into it here. So first off, what is hydrokinetic energy? So basically, I like to think of it as kind of like an underwater wind turbine at its base form. So it's a form of renewable energy in which you have this turbine in the way of a natural flow of water, and when the water pushes on it, it turns just like a wind turbine, except underwater, obviously. So it sounds a lot like hydroelectric power, which is what you get from dams and things like that. And it's close to that, but it's a little different. For hydroelectric power, like in dams, you redirect the water into wherever you want it to go. So like um, this at the bottom is a picture of the inside of the Hoover Dam, and obviously there's not it's not underwater right there. Um, and then on my left is uh, a, a drawing of an underwater wind turbine, essentially. So one of the big benefits is that hydrokinetic energy is less invasive because you don't have to block off a giant portion of the water, so it doesn't invade wildlife as much. And also, it's easier to have something already in the way of the ocean water, since oceans can be so volatile with tides and currents and other things like that. So it is going to be really effective, I believe, in the future, but it's still a new technology and people are still working on it. So it still costs a lot of money to um, have these new technologies. So for one thing, there's no standard model yet that any company that wanted to invest in this could just buy or use, or another country. You All of the ones that have been created so far have been through private industry and custom order, and they're still being experimented on and seeing if they work with the right amount of water and things like that. Yeah, so they need to be monitored. Since they are experimental, you want to make sure that they output the right amount of electricity, and that they don't harm any wildlife. They are quicker to wear and tear than wind turbines, like in the picture behind me. Since they are underwater, water will erode them faster than air, um, just because of the water hitting it, but also water carries things like silt, sediments, sand, things like that, which will erode it faster. And the acidity of the salt water will corrode whatever material you make it out of. And also, there's been constant innovations with this sort of project. It's been happening. The earliest one that's been tested was maybe 15 years ago, but with this sort of thing, uh, in 10 years from now, the models that they have and the models that they have in 10 years from now are going to be cheaper, and they're going to be more effective, and they're going to be making more power. So for a company to invest in something like this now doesn't really make sense when you could probably wait 10 years. Furthermore, it's still cheaper to use wind power for the same size turbine. The hydrokinetic one will only it costs around the like $1,200 per kilowatt hour, and the wind turbines only cost you about $700 per kilowatt hour. So the wind turbines still make sense as of now, but in the future, the hydrokinetic energy will be more viable. So there's a lot of different types of turbines that they have so far. So the first one that they started with, the first company that got into it is Verdant Power. So their model is the one on the right, and it really is. It just looks like an underwater wind turbine. It's secured to the ground, and they secured it pretty hard. You can see in this illustration. So they started doing stuff in the 2007, 2009, in that area. And what they found is that it works, but since it's just secured to the ocean floor, it's not quite as sturdy as other things should be, and it is susceptible to being pushed over when in tropical storms and things like that, because the currents and the water pressure work so heavily against their design. And then it's susceptible to being pulled up and pushed around, things like that. So another design was Skotren Wobbles SR250, and that's the yellow one up in the corner. And that one actually floats on the surface of the water, which has some different benefits and disadvantages. So it's not susceptible to being pushed around by underwater ocean currents and tides and things like that because it's floating on top of the water. And then in the event of strong ocean, like a tropical storm or things like that, they can actually pull up those bottom two turbines to ensure that it doesn't get damaged. And because you don't have to secure it to the ocean floor, it's actually a lot cheaper to make, even though it looks a lot bigger. And then this open hydro one, the one in the last one I haven't talked about yet. That's a different design where the center is actually hollow, and the energy is created around the outside, so water is pushed through it and it spins. And that one's kind of interesting because there was a company that wanted to install one near Snohomish, Washington. So it's interesting to see that things like this are actually happening in the world, and they're happening in our neck of the woods. So we'll move on here. And then there's another different type of turbine. This one is the ORPC RivGen. And this one's really interesting because with all the other ones, you had water moving in a straight direction, and then it would push the turbine, just like what happens with wind turbines. The wind blows in one direction, and it hits the blades, and it spins. But with this one, it's built differently. So it's in a spiral pattern, and they've got a little diagram at the bottom with how they worked out all the math and how everything works. And that's super interesting to look at because it's crazy to think that people had designed different ideas for this and different things that worked and then built it and tested it. And this is actually one of the more effective ones so far. So that's one of the things about in 10 years from now in the future, these are just going to be more effective and more viable and cheaper cost. And yeah, so you can see these things are really big. You can't really tell from the diagrams and the pictures, but they're gigantic. So it's really cool to see just the actual size of these things. And then, so one of the important things is that it's important to keep ocean life safe. That's one of the reasons you would use hydrokinetic instead of hydroelectric, because it's less invasive on the environment. So you can keep all the habitat safe because you want to keep green energy. You know, if it's reusable, but you're destroying the habitats of animals, then it's not really helping the planet as much as you might think. So every site that they have is surveyed so that they can ensure that it won't disrupt the habitats there. And also it needs to have the right general conditions. So the water has to be deep enough. Obviously those things are really big, so you have to have a wide enough channel for it to go in. It can't have too much traffic from ocean life or from people and things like that. You don't want the water, at low tide, if you have waves, you don't want any part of the turbine to be above the water because that would cause more erosion and it wouldn't generate as much electricity. And you have to have the velocity of the water to move fast enough. So they're saying it needs to be moving at least 2 to 4 knots at all times, and ideally it would be moving about 5 to 7 knots. But as I was saying, it's really important to keep all the ocean life safe. So like, you want to keep all the fish safe. You don't want to hurt any of the fish. We've got crabs. You want to keep all the crabs safe. Everybody loves seals. You want to keep all the seals. Not that seal. You want to keep all the seals safe. Not that seal either. There it is. You want to keep all the seals safe because we all love seals. They're super adorable. That's one of the most important things to consider when discussing hydrokinetic energy. And that's the end of my presentation. Thank you so much for watching and being here. And if you have any questions, please contact me. Thank you so much.